students, today we are going to start the new paper, that is paper 2, unit 1 of the paper 2, that is a physical chemistry, the chapter chemical kinetics. You know that chemical kinetics that deals with the rate at which the chemical reaction takes place, the mechanism by which the reaction takes place, and also the influence of the various factors such as the temperature, pressure, concentration, etc. on the reaction rate. What is the chemical kinetics? It is a study of the rate of the chemical reaction that may come for the MCQ purpose. A quantitative study of the reaction kinetics has an important role in such a diverse field as the biochemistry, production of the chemical, medicine, etc. Every chemical reaction takes place at a definite rate depending upon the conditions. Okay. Now, then there are the important thing is that again the MCQs will be based on the homogeneous system, homogeneous and heterogeneous. If all the substances taking part in the reaction are in the same phase, the reaction is said to be homogeneous. Whereas, if the more than one phase is involved in a reaction, it is said to be the heterogeneous. Okay. Then rate of reaction. The rate of chemical reaction may be defined as the change in concentration of any reactant or any product per unit time. If in a given case, reactant having the concentration C at a time t is chosen, then rate of reaction is equal to minus dC by dt. The minus sign indicates that the concentration of the reactant decreases with time. On the other hand, if the product is having the concentration X at a time t, then it is written as rate of the reaction is a dx by dt. Okay. The definition of the rate of reaction may come for this particular MCQ, or say these two cases will become for the MCQs. That minus sign indicates that concentration of reactant decreases with the time. It follows from the above discussion that the rate of the reaction must have the units of the concentration divided by the time. That is, rate will be in concentration per time units. Concentration are generally expressed in mole per dm cube, or if gases are involved, it is expressed in the kilopascal. Time is almost always expressed in the seconds. In this case, the rate of the reaction will have the units mole per dm cube per second, or kilopascal, kilo per pascal, or Newton per meter square per second. Kilopascal per second, or say Newton per meter square per second. According to the law of mass action, it may come for the MCQs. Unit may come for the MCQs. According to the law of mass action, the rate of the chemical reaction at any instant is proportional to the active masses, or say molar concentration of the reacting substance at that instant. The rate of chemical reaction is proportional to the active masses or molar concentration of the reacting species or substances at that instant. That may come for the MCQ. Then for a given initial concentration, the reaction rate is maximum at the beginning and the rate steadily decreases with time. This is because concentration of the reactant decreases with time. Theoretically, infinite time would be required for a reaction to be complete or its rate to fall to zero. But the reaction rate becomes so slow after a certain time that for all practical purposes the reaction can be considered to be complete in a finite time. Since the concentration changes at every instant, there is no simple method to determine the rate of the reaction directly. The concentration of reactant or product is determined at various time intervals, and a graph of concentration against the time is drawn. A smooth curve is obtained, as shown in this figure. The slope of the curve at any given time gives the reaction rate, that is a minus dc by dt or say dx by dt. You can see, you can plot both the curve. This is for the reactant, this is for the product. Okay, this give the negative value, it will gives you the positive value. Slope is equal to dx by dt. Here slope is equal to minus dc by dt. Okay. Then measurement of the reaction rates. Temperature has a considerable influence on the reaction rate. Temperature affects the reaction rate. That may come for the MCQ. Consequently, when a kinetic study is made of the reaction, temperature is maintained constant. A reaction mixture of the known composition is prepared and placed in a thermostat, a device for maintaining constant temperature. A reaction can be quantitatively followed either by determining the decrease in concentration of reactant or increase in concentration of product with respect to time. The actual method used in finding the concentration changes with time depends upon the nature of the reactant and the products. A commonly used method is to remove sample of reaction mixture at defined time intervals, stop the reaction by chilling them or freezing them, and analyzing the sample by titration. Sometimes the reaction is started in several vessels at the same time. The content of the vessel chilled at different time intervals and analyzed. The chilling must be very quick so that the concentration change may occur when the sample is being chilled. This is generally done in the laboratory by running the reaction mixture into powdered ice. Since a change in the concentration occurs during the course of reaction, physical methods are also used to follow a reaction. Variation of the conductance, refractive index, viscosity, light scattering, etc. are the common physical methods. The volume of a gas evolved during the reaction is also used. In case of reaction in gaseous phase, the total pressure is usually employed. If the substance under study is optically active, the reaction can be followed by determining the angle of rotation by mass means of the polarimeter. Order and the molecularity of the reaction. The number of molecules whose concentration determine the rate of reaction is called as the order of reaction. That may come for the MCQ. Means here the example is given. Rate of a chemical reaction is proportional to the nth power of the reactant A and nth power of the reactant B. So then rate of reaction is equal to Kca Na into Cb Nb into where K is proportionality constant and the overall order of reaction N is given by N is equal to Na plus Nb plus . This equation number 1.13 is called as the rate equation, and such a reaction is said to be nth order with respect to A and nth order with respect to B, and so on. In other words, the order of reaction is also the sum of all the exponents of the power to which the concentration or pressures are raised in the rate equation. If the reaction rate is proportional to the first power of the concentration of one reactant, then the reaction is said to be the first order reaction. If the rate is proportional to the product of concentration of two reactants, the reaction is said to be second order, and so on. If in the reaction only one substance is involved, then in this case the order of reaction is N. Another method of the classifying reaction is terms of the molecularity. The number of molecules or atoms which take part in each step leading to chemical reaction is called as the molecularity of the reaction. Reactions are called unimolecular, bimolecular, etc. depending upon number of molecules involved in the reaction. Thus, if one molecule breaks up into smaller parts, the reaction is called unimolecular. If two molecules have to come together before a reaction can take place, then the reaction is said to be the bimolecular reaction. Here, example is shown. Br2 gives the twice Br, that is the unimolecular reaction. N2O5 gives you the N2O4 plus O2, it is a unimolecular reaction. Here, I say that methyl acetate along with the water is there, it will give you the acetic acid along with the water. Here, the H2 plus I2 is there, it will give you twice HI. These are the bimolecular reaction. In many cases, the order and the molecularity of the reaction is the same, but there is no necessary correlation between the two. The hydrolysis of methyl acetate and ester takes place according to the following equation. It is apparent from the equation that two molecules, one each of methyl acetate and water, are required for the reaction to take place. But since water is taken in excess, its concentration remains virtually constant. Consequently, even though the reaction is bimolecular, the rate of reaction depends only on the concentration of methyl acetate. Hence, the reaction should be therefore first order. Such reactions are called as pseudo first order reaction. Why it is called as pseudo first order reaction? Because water is having the constant, means whatever the rate of the reaction will depend upon the concentration of methyl acetate. Okay. Then we have to see the difference between the molecularity and order. The number of molecules taking part in the step leading to the reaction is called as a molecularity. The order of reaction is the sum of the powers of the concentration terms in the rate equation. Second point, the molecularity of the reaction is theoretical concept, whereas the order of has to be determined experimentally. And third point, the molecularity of the reaction is always integral whole number. And third number, or in the order can be integral or fractional. Molecularity cannot be zero, order can be zero. Molecularity does not change with concentration, order can change with the concentration. Molecularity does not indicate anything about mechanism of reaction. Order depends on slowest step of the reaction, hence helps to understand the mechanism of the reaction. Remaining part we will see in the next lecture. Please go through this part. Here this differentiation point are there that may come for the MCQ purpose. Thank you.